a program right here that's going to show the difference between doing something um, non-concurrently and then concurrently in Go. When I started doing concurrency, it was kind of tricky to me, and I thought if you saw a program that wasn't concurrent transfer to something that is concurrent, maybe it would help some people. And I'm going to be showing how to copy from one file to a new file. There's better ways to do it than what I'm about to show you, but this is a good way that shows how you can build concurrency into something. So first declare our package, our main function. So we're going to be timing this, right? And then done in, and then we're going to say at the end, so this should basically just say, hey, it started here and now it's ending here. What? Printf. And if we ran that, it would just say, hey, you're done in 197 nanoseconds. Okay. First, we need to open a file. I've got some code above here that I'm going to copy and paste. It should just make it faster for us, so I don't have to live cut everything out. So first, we're opening a file. We're opening os.open, and lollipop.zip is about 500 megabytes, I believe. So it's not exactly a small file. It just makes it better. It makes it easier to see the difference between when you do it concurrently and non-concurrently. And then we're going to be lazy, and just if there's any errors, we're just gonna be lazy and fatal. I'd rather call this in than out. It makes more sense. And here's where we're going to be reading to. Let's call this out. And we didn't defer our close of our open, so defer in. Currently all we're doing, we're opening a file called lollipop.zip, checking if there's an error, failing if there is, and then deferring a close if there was no error. And we're doing the same here, except we're creating a file. And these both return an os.file or a pointer to it. So we're able to treat these files the same. And we're going to be using f.write at instead of f.write, just because it'll make it easier to implement later. For here, it's for this non-concurrent application, it's going to be the exact same, but we need to keep track of a marker. I'll explain that later. It's going to be in64 because it's pretty big. And then start a for loop so we can iterate over a file just over and over and over. And we're going to have a to read amount of 10,000. Actually, let's do 100,000. So we're going to read 100,000 bytes at a time. Now we're going to create a slice of bytes. Oops. And allocate the to read amounts to it. So we're going to read from in into this P right here, this slice of bytes. And we're going to say the byte count and the error from in.read into P. So we're reading from in to P. And it's going to give us the amount of bytes that we've read, which should be the same as up here, if not a little bit less towards the end, and then an error if there's an error. So to check for these errors, when you're reading from a file, you have to say if the error is not nil, then if error equals, let's see, it's io.end of file, then that's an okay error. Return, that's not that bad. It's a good error. That means we're done reading the file. If it's not, then we're gonna go ahead and be our lazy selves here. That fatal line. I didn't do the same here. All right, let me just copy this guy. All right, that works. Just gonna do that over and over again until we've read everything. And then down here we can say print format, read this amount at the position of marker. So we're going to say byte count and then the marker. Now what we're going to do, we're going to write into the new file. We don't care about the bytes that we're reading into it because we kind of know that with the to read amount. And then Error is if there's an error, write at. So you could usually do write. You just write the bytes. It's not that big of a deal. I'm just going to keep it like this because it makes it easy to do concurrently later when you see that we're doing basically the exact same stuff. So we're writing the p bytes at marker. And then if there was an error, we're going to fatal line saying there's no new variables, I'm guessing. Yeah. Next thing we want to do is actually let's do that. Red %p bytes to marker. So yeah, it's basically posting the same thing, just saying from red to right. Next thing we have to do is increment our marker. Oops. We increment our marker the amount that we read, which is why we kept it as a variable, not just a number floating around there. So this should work. We're just reading and writing over and over and over until it hits end of file over here, and then it just returns out of here, and it should log how long it took. And okay, it didn't write how long it took. Oops. Okay, done in 2.9 seconds. We're going to keep that on the screen. Going to keep that up here. Remove the test.zip. Now let's make it concurrent. First thing, most of this stuff is fine, but we don't need this in the main function anymore. We're going to put this somewhere else. Let's create a type that's, well, first let's create the function here. What's that read? Is that right? io.Reader. I'm dork. This can return a channel that we can read from that we haven't implemented yet. So the io.Reader, it's because os.create and os.open both conform to it, so that's fine. And our partial is going to be the exact same as we had earlier, where it's got it's got a marker and then it's got bytes. So we're just taking that logic out of here and putting it into a type now. It's not a marker, it's a partial. It's going to have the data, which is your slice of bytes, and then your marker at N64, which is where the data is being held. And now what we're going to do for here, we're going to create our channel. Very first thing we do, just call it out. It's kind of idiomatic, at least for me. Make and partial. And we're just going to give it a buffer of 5. So that means if we wrote one partial in here and it's reading over here, it's not blocking anymore because we can fit 4 more before everything is blocked, and this is waiting for something to be read before it can fit another one in it. Return our out. So it stops complaining right here. Okay. Now we're going to create a go routine. The very first thing we do is defer the close of that channel. I believe this is called a generator if you're looking at concurrency patterns in Go. Now what we're going to be doing is creating that for loop, an infinite for loop. And actually first let's create a marker. Oops. For our marker is our N64, and then we're going to be reading that that's the amount that we were reading before. It's the exact same amount, so that should work. Next thing, we're going to create that slice of bytes. Byte, and then the increment amount. So I believe I called it toRead before, it's just increment now. Next thing, we're reading from F. Let's actually read these bytes. Don't worry about the bytes anymore. we're reading from this file into this this slice of bytes here, and then checking for the error. Remember, we have to check if it's in a file first. Return, we don't care. If it's not, then the entire world is coming down on us. Just log fatal. Why? Oh, my bad. We don't need this as a pointer anymore, that's right. Okay. So next thing we're doing, after we read into it, let's see what else we have to do. Let's pipe it down, pipe out through our channel. So out is going to take a new partial with the slice of bytes. Let's call it this data equals p marker marker. And next thing we have to do is just let's do it once. We're sending out to that channel and then just saying we're reading from that marker, or we just read from that marker. And then so over here, when we write to it, we'll be able to say we wrote from that marker, and then increment the marker. Now we're doing marker is plus equal the N64, the N64 amount over here, that or the increment here, so the 100,000. So this should work down here, but now we need to implement it up here. What we could do is say for p read in. So what we could do is we could say for every time some data comes from in, we could just say out, actually out.write at p.data p.marker. And check if there's an error and log fatal if there is. So this should work, but there's a hiccup. Let's see. See if you can spot it. It's still not concurrent. So it's still done in about the exact same time. The reason is because we have to spawn a go function in here as well. So we can just copy this. Let's see, do it inside of a go function here. But now, first let's do this, out.write marker, okay. It's going to give us an error. It should give us an error, yeah. It's going to say variable p captured by func literal. It's saying we have to pass in this p as a parameter. So p partial and then pass in the p here. This will work. Now if we ran this, what would happen is it would send a whole bunch of these out into the ether and then instantly end the program. So what we actually need to do is have a wait group, so we wait for all those to be completed. That's not a function. So there's our wait group, and we're going to wait right here. And for each read from in, we add one to our wait group. And then inside of here, we're going to say defer wait group done. The reason why you can access the wait group but not the read is because you can't access something coming from a range loop when you have an anonymous function within the range loop. So range, no. Anything else, I believe, yes. Now this should be good. So it's 2.2 seconds here, 2.9 seconds here. The other thing we have to do to make sure it runs concurrently and fast concurrently is the snippet code here. So what we're going to do is we're going to say run on max processors. Here's the processors that I have. It should return 4, and then this just says you run on all those max processors. I'm not counting that one. We're just counting the time it takes to do our task. So done in 1.8 seconds. We did not log a write. We could do that though. You can see it's done in a second faster because we're able to send in 5 bits of our file here and then read it 5 different times over and over and over here. Every time it's done, it decrements the wait group, and then as soon as all of them are done and everything is closed, then we can end the program and say it took this amount of time. So that's how you have a non-concurrent program, and you can change it to be concurrent. Remember, it's not idiomatic because you can use, I believe it's like io.Copy to copy from a reader to a reader, or a reader to a writer. But this is just kind of showing you how concurrency can work.